Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen, wherever your Zoom controls are. You should see a Q&A button. Click on that, type in your question, hit submit, and I'll get to those at the end of the session. If you're watching on YouTube, just use the live chat function wherever it happens to be on the device you're using. Type in your question or comment, and I'll get to those at the end of the session as well. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 9 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. And before I did that, it was a couple years as a diagnostic sales rep with Snap-on. So I had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So over time, working at the dealership just became the go-to diagnostic guy in the shop. It's always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher problems that would come into my bag. Then before that, bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is hybrid operation and testing. And this is by no means going to be a deep dive or really technical laden hybrid class, because there is a lot of technology involved with these. It's going to be a good overview, get your feet wet basics type of class with the hybrids and how they work and so on. So with that, let's start off at the beginning. Well, what in the world is a hybrid vehicle anyway? So a hybrid combines at least one electric motor, could be more than one, with a gasoline engine to move the car. And the system recaptures energy via regenerative braking. We're going to talk a little bit more about that in a few minutes. Now, sometimes the electric motor does all the work. Sometimes the gas engine does all the work, and sometimes they work together. So it's a hybrid between a gas and an electric car. It's kind of a melded together gas and electric vehicle. So it has a normal gasoline engine most times, and then an electric motor and a battery and so on. So we'll talk about all the different components and how they work together here. So first off, let's talk about the different types of hybrid powertrains, because there's a few of them out there. It's not just one that's used in the industry. But the most common one that's used out there is going to be what we call a parallel system. So gas and electric motors are used in combination to drive the vehicle. So they're linked to a common transmission. So the electric motor can drive the car, or the gasoline motor can drive the car. Generally, the generator and the motor itself are going to be grouped in the transmission. And a lot of times manufacturers have resorted to CVT transmissions as well, just to make them a little bit more compact, I guess you could say. But we'll see, we have the engine over here. We have the generator, it's smack dab in the middle. We have the transmission with the planetary gear set in there. And then we have the electric motor over here, and that is all kind of one package. But you can see where the transmission would split from the engine there in the bell housing. So that is kind of all one assembly. A lot of times it's not even really serviceable separate. So you just buy a new transmission or electric motor. Hybrid drive assembly, I've seen it called a bunch of different things. So that is the most common one. That's the one you see in like the Prius and the Volt and things like that. Definitely the most common one out there. Then there's another one that's called the series system. So this one has the electric motor in there, and it drives the transmission. And the only thing that gas engine is there for is to charge the battery. So this isn't as common, I should say. I don't know how overall how common it is, but it's not all that common. I was able to find it in like the BMW i3 with the extended range option, because the i3 is actually an electric car, but the extended range option adds the 600cc motor out of a BMW scooter is actually what they use. It's a little tiny thing, and all it's there for is to turn the generator to charge the motor. That's all it's there for. A lot of consumers, vehicle drivers, find this a little disconcerting too, because the engine doesn't always start like on a normal gas engine vehicle where you press on the pedal and maybe the engine will go. In this case, you could be halfway through an acceleration and the engine will turn on, or the engine turns on while coasting. It only turns on when we need to charge the battery. So it's kind of a disconnect there. So some people find that disconcerting with that. So just that's probably why it's a less common design, I would think. And then we have kind of the newer kid on the block, which would be our plug-in hybrid vehicle. So this picture happens to be out of a Chrysler, and this is the plug-in minivan. It is starting to become more common. Chrysler has it. The Prius has it. A lot of other vehicles are starting to resort to this plug-in type hybrid. So the plug-in really is what charges the battery. It still can charge the battery with the motor, and it still can charge the battery with the regenerative braking. But it does have a much larger battery in there, and it gives you the much greater range in there. And the gas engine is used only under higher load conditions. So the story goes with this Chrysler engine, it's a 3.6 Pentastar motor mated to this hybrid powertrain. And so the story goes is if you're just using this as a minivan, driving around town, doing errands, shuffling kids to soccer games in school, that gas engine may never turn on because you get a really good range with the electric motor by itself. It's got two electric motors actually, but you get a really good range with the electric motors and the battery pack. So you may never need to waste or use a bit of gasoline in there. So that's kind of an interesting concept they're using to get even more range out of really more of an electric powertrain, and then just add the gas motor to it as well. So let's talk about the different components. So those are three main types of configurations. Now let's talk about the different components that we'll see in there. Of course, we have the battery, right? We talk about the electric motor and all that. So the battery there and the battery cooling system as well. And actually, it's a battery warming system in some cases. We also have the generator and a voltage converter or inverter or both. Regenerative braking system, which kind of uses the electric motor. As I said, we'll talk about that. And then the electric motor itself in there. So first off, let's make sure we're thinking safe. Right? We're all about safety here at Snap-on. So this is high voltage in both ways. So we can have 500 volts AC. We can have 400 volts DC, depending on the system. So we want to make sure we're being very safe. Anything over 60 volts DC can be considered high voltage. So a high voltage fuse, this is all from Toyota, from a Prius. So a high voltage fuse provides short circuit protection of the high voltage battery pack. Positive and negative high voltage power cables connected to the high volt battery pack are controlled by 12 volt normally open relays. We'll talk a little bit more about those in a little while. When the vehicle is shut off, the relays stop electricity flow from leaving the high voltage battery pack. So hopefully it keeps it contained and we don't have a problem that way. Warning, the high voltage system may remain powered for up to 10 minutes after the vehicle is shut off or disabled. To prevent serious injury or death from severe burns or electric shock, avoid touching, cutting, or opening any high orange voltage power cables or high voltage components. So really anything with the orange cables and anything that those are connected to, those ones you want to be very careful around. As it said, up to 10 minutes. So you probably want to leave it a little bit of time. If you look through the shop manual on this, there's like signs you got to put on the roof, and you want to rope it off, and you want to use heavy rubber gloves and an apron, and there's special tools, screwdrivers. I'm sure you've probably seen those before, the orange handles made for working on this type of stuff. So there is special tooling and there is safety gear that you want to be aware of when it comes to working on these vehicles, because you really don't want to get hurt. This might not be something that you want to get into, and that's fine too. There are specialty places that'll take care of this. The dealership will take care of it too. But I figured the more you know, the better prepared you can be if you do have one of these vehicles come in the shop. Both positive and negative power cables are insulated from the metal chassis, so there's no possibility of electric shock when touching the metal chassis. A ground fault monitor continuously monitors for high voltage leakage to the metal chassis while the vehicle is running. Because remember, when it's off, we shouldn't have any voltage coming out anyway. If a malfunction is detected, the hybrid vehicle computer will illuminate the master warning light in the instrument cluster and indicate check hybrid system in the multi-information display. The high voltage battery pack relays will automatically open to stop electricity flow in a collision significant to activate the SRS or supplemental restraint system or airbag, however you want to call it. It's all the same thing. All right, so we want to make sure we are being very safe. We don't want to get hurt. Now let's talk about the battery, the source of this pain and suffering that we could endure if we do have a problem here. But it is built of multiple small low voltage batteries that are linked in series. So you'll have a much smaller voltage and then they just tie them all together to get us a much higher voltage. Results in a high DC voltage, could be 300 to 400 volts plus, depending on the system. A lot of them run around like 200 so, but it just depends on the vehicle. It could be a nickel metal hydride or a lithium ion battery, depending on how the manufacturer decided to have it formulated. You know, like everything runs on lithium ion nowadays, but there are nickel metal hydride vehicles out there as well. So just so you're aware, there's a couple different formulations in there as well. And a battery being a battery, charging and discharging and so on, that takes a lot of heat. So batteries need to be cooled in order to maximize their performance and their life. If they get too hot, it's going to not last as long. If it gets too hot, it's not going to perform at the optimum way that it's supposed, that the manufacturer wants it to perform. So there's 3 different main methods that are used in order to cool a battery bank. So we have passive air cooling, which is fairly simple. It's just that there's vents to the outside. When the car is moving down the road, the air goes in the vents, they go over the battery, and they go out the side or something. So that's passive. Active air cooling is shown here. This would be off a Prius. It's just a big blower fan, basically. Sucks in cold outside air, blows it over the battery chamber, escapes out the other end. So allows it to cool it. And then also liquid cooling as well. So in the Chevy Volt, I know there's liquid cooling. There's a couple other manufacturers that use it. Toyota uses it to some extent as well. So here's an example of a cooling system for battery cooling system on the Chevy Volt. So you see we have the battery cooling system radiator, which is up there with the condenser and the engine radiator. A lot of radiator fins up in the front here. You can see there's also a 12-volt coolant pump, which sends the coolant through a 360-volt coolant heater. So that operates off the high voltage off the battery. And then there's a 3-way coolant flow control valve. So if we want to cool it off, we go through here. If we want to heat it, we want to cool it off even more, we can go through a chiller. And then if we want to heat it up, we can go through this circuit right here, which just runs it back through the heater. Because if you think about it, it needs to run at whatever that optimum temperature needs to be, probably 70, 80, 90 degrees. I don't know what it needs to be, but whatever that happens to be, if it's 4 degrees out like it was at my house this morning, that's Fahrenheit. It's 4 degrees Fahrenheit outside. You may need to heat it up in order for it to work too. So it can use the coolant and a heater in that way as well. As I said, 360-volt heater. Also a 360-volt AC compressor on this car too. And it uses DexCool with deionized water. That's another key right there too. So if you're ever going to replace this stuff, you want to make sure you use that specific, make sure there's the deionized water in there, because the deionized water won't conduct the electricity. Ionized water can conduct electricity much better than deionized water. So you want to make sure you're using that deionized water. That's another safety function there too. And as I said, the coolant can be either warmed or chilled. Other manufacturers do it in different ways, how they warm the batteries. But that's just one example there. And we do need to bleed this pump if we do any work on the system. There's functional tests for that. Bunch of different things that we can do. And also, by the way, this just made me think about this. I was going to mention it earlier, but a lot of the functions we can do on this, since it is such high voltage, there's not as much guided component testing. There's a few things maybe on like this pump and stuff. But when it comes to hybrid vehicle diagnosis, a lot of times you're going to be using scan data, checking battery voltages and things like that. So just be aware it's more scanner side than scope side in this case. Granted, our scope is capable up to 400 volts DC, but we run at 500 volts DC, that would be a problem as well. So there's not as many component tests with this. So we talked about the battery. Now we have the generator, right? So it's used by the engine to charge the battery. It's also used to start the engine. That's another key right there. You may have noticed, if you look back on that picture we had earlier, there isn't really a traditional starter on a lot of these vehicles. So oftentimes the computer will use the electric motor to turn the engine. Kind of like if you've ever driven a stick shift and you've had to pop start it. That same type of thing. So it rotates the engine fast enough to get it to start, usually 9 to 1200 RPM is what I've been seeing. Using this planetary gear set here, it runs the engine, starts it up, and then when it's able to run, it runs. So it actually uses the generator bits in order to do that. Also, this generator outputs an AC voltage, so that'll come into play in a little bit when we talk about, or right now actually, when we talk about the converter inverter. So on many of these vehicles, it'll have some sort of a conversion or inversion that needs to happen. So this is the one off of Prius again. I just kind of went to Toyota's website and they had a lot of marketing pictures, so it was really useful for that. How about it converts AC to DC and DC to AC, depending. It steps up voltage from 200 volts to 500 volts, 200 volts DC out of the battery to 500 volt AC to run the electric motor in the Prius. Other manufacturers use different voltages, but reverses the step up to charge the battery while braking. So it takes that AC from the electric motor, and then when it's under regenerative braking, goes back through this converter, converts it back to DC so it can charge the battery. Right, so it kind of works in both directions. If we want to look at a schematic as to how that would work, we got that main fuse that we talked about. There's the high voltage battery pack here. There's that main fuse. That fuse can trip when there's a voltage problem, or it can trip when we get in a collision as well. High voltage cables are here. You'll notice 200 volts, 201.6 to be exact right there. And then that also sends it down to the compressor, which runs off the high voltage as well. Normally open relays are here. That's the thing that removes the voltage from the system when the car is off. So these relays are normally open. And then we have the high voltage computer right there. And then the inverter converter. And I also want to draw your attention to the fact that we are running out of the generator into the inverter in 3-phase AC. And we are also running the electric motor off of 3-phase AC. And then the rest of this is on DC high voltage. So a little bit of difference there. We're not usually used to running AC on a normal car, so to speak, a non-hybrid vehicle. So that's just good to know that there is AC voltage going around there, and it's 500 volts run that motor. So also there is a 12-volt battery. This is usually used to power like the radio and the HVAC and things like that, things that normally would be 12 volts in a car anyways, the lighting, stuff like that. So that's really what that's for. It's not used to start the car. As I said, you can probably change that battery as many times as you want. If you get a no start condition on one of these cars, it's probably not going to start that engine up. So just be aware of that. That oftentimes they don't have a normal starter. They don't have a normal starting system. They'll start off that battery pack. And then we talk about the regenerative braking system. So that transfers energy from braking in order to charge the battery. So it uses the electric motor like a brake. So as I mentioned before, like pop starting a vehicle, if you ever go and shift to a lower gear to slow down the vehicle, same type of idea. Takes that energy we're using to slow down the vehicle with the gearing and turns it into electrical energy. So we can see the energy coming off the wheels and then a motor and then charge the battery. Now, hydraulic brakes are still used on these cars, of course, but it's usually used when I need supplemental slowdown power. So we could slow down pretty much to a stop with the electric motor, but I think the hydraulic brakes will really come in when we need to stop. And then when we really need to stop, like under an emergency or panic stop type situation, it would happen then as well. So that's regenerative braking, works in reverse through the electric motors. Simplified version of how that works. And that brings us to the electric motor. So as I said before, it is high AC voltage, 500 volts plus. You can see all the windings in there. It's used to drive the wheels. There can be one or multiple electric motors in there. It's also used, as we just said, to charge the battery during regen braking. And most that I've been able to find are a 3-phase AC motor. They'll run off alternating current out of a converter or an inverter. All right, so let's look at a case study. This is kind of an interesting one we got from one of our Snap-on folks over in Ireland. His name is Damian Coleman. He's the product manager and experience-based information specialist at Snap-on Diagnostics. He's actually in charge of all the vehicle communication software on the vehicles now. So this one came from him. He was working on this Prius one day and working in a shop. And the customer complaint was intermittently the vehicle would not enter ready mode. And we need to have ready mode in order to drive down the road and get this vehicle moving. There were malfunction indicators on the dash as well. And there were codes present in 2 systems. So we had the hybrid control module itself, had a P3000, which is battery control system. And then the battery control module had a P0 AFA, which is hybrid battery system voltage low. So according to this, had a low system voltage. And it won't go into ready mode unless the voltage is a certain level. So that's kind of one problem. It's kind of maybe leading us where we need to go. So upon inspection, they found the high voltage system would remain inactive as the high voltage contactors, these guys right here, these system main relays, 1, 2, and 3, they were not being switched on by the high voltage control module. So the control module needs to be able to turn these on. As you can see, we got the high voltage computer here, and we have circuits that go to the coils inside the relays. System has 3 SMRs, or system main relays. So number 1 is the positive contactor. You see it comes off the positive pole of the battery, goes there to run to the inverter. So that's the positive side. And then we have number 2, which is the pre-charging resistor. So pre-charge function is to limit the initial supply of current from the high voltage battery to the inverter. So when we first start out, this number 2 and number 3 will turn on, and that limits the amount of current. And then when we finally need their max current, then number 1 will come on as well. And then number 3, as we said, is the negative side of the battery. So these relays, these are the ones that they said turn off when the vehicle is off. So in order to turn it on, we need to have this ECU give the signal to say turn on. And as I said, there are a couple different statuses of these 3 different relays. So when it's in ready on, stage 1 will be on, off, on. So on the positive, on the negative, off on the that's middle relay there. Stage 2 will be off and then only on the ground. And then stage 3 is everybody's off. So I guess in this point it was stuck at off. Everybody was off. High voltage system off. We get positive is off, negative is off, and then the that step down relay. Stage 2 is when we start charging. So step down relay is on, and then the negative is on, and then all of them are on stage 3, and then we just go to positive and negative on stage 4. So that's when I'm fully running. I only need positive and negative at that max current. So this led them to the battery. Let's go take a look at the battery and see what's going on. So on this vehicle, it has 14 14.4 volt blocks. Remember how I said there these EV batteries and hybrid batteries are made up of multiple blocks of much smaller batteries. You can actually, there's people I've seen actually go in and change out individual cells if they have a bad battery, and you can actually get a reman battery nowadays as well. So each block in this case was made of 2 7.2 volt cells, as a positive and a negative cell. Total voltage, if I were to add those all up, 14 times 14.4 gives me 201.6 volts DC. So it's a 200 volt battery. Once again, remember safety first. Anything orange we want to be careful of. And also, if we're going to work on anything in the system, we want to wait up to over 10 minutes, I would say, just to give it a little extra leeway. And then we also have the service plug right here too that we'd want to disconnect from the system to have the battery just kind of self-contained at that point. So we want to disconnect that service plug before we work on it. And you'll see right there, measured voltage, 228.2 volts. So we don't want to get too near that. So here's a diagram of how those battery blocks work. So this is my battery control module. Remember, we have a sensing wire to each of the battery blocks. Here's the negative block, positive block, and then they're tied together with a bus bar. So we have the positive connection, the negative connection, and then that bus bar goes in between. And then on this negative one, we go out to the negative cable. On the other side, be positive on the other cable. So here's an example of also here's the control module right there. There's high voltage, goes to high voltage. There's the positive and there's the negative. And on this negative wire right here, there's also an amp clamp or a current clamp that reads the current flowing through into and out of the battery pack. So we can see how the current is flowing, and the computer uses that to make some of its judgments on that as well. So as I said, not a lot of component testing on this, more of a scanner test on this. On this vehicle, and lots of vehicles like it, you can go through and look at battery voltages of each individual battery block. So as we can see, we have 4 on the screen right here. This is on like an Apollo or a Triton would look like this. We can see 2 of these are normal and 2 of these are definitely not normal. And now if we were to compare these 2 down here, if we scroll down a little more, you'd see other blocks would look fairly similar to this. This is normal operation with this. Up here, we have an abnormal running from negative 15.83 to 16.14. So it's going negative 15 volts to positive 16 volts. That's really not possible. So they need a little bit of further investigation in this case to say, hey, that battery's messed up. So they actually decided to disassemble the battery casing. Now, as I said, this may be something you want to get into, maybe something you want to avoid at all costs, and that's fine as well. But this is that they were all game for doing this, so they headed in, pulled off the bus bar here, and you can see where my connectors are, and then you can see the bus bars there made of copper, and a few of them were corroded. So you can see how they're kind of dirty there. We can see the fancy toothbrush over here they used to clean them all off. So they cleaned them all off, reconnected everything, reassembled everything, and went back together. Still had the problem even after they put it all back together. So they said, all right, let's investigate a little bit further. Found out in the high voltage battery control module as well. You can see we got some green fuzzy stuff in there. It's all corroded as well. So that was a problem. So they had to end up replacing this whole module because of that. So they cleaned the battery contacts internally, replaced the module, got that all done, and then they decided to double check their work. So fault was cleared, went away. This image shows those battery blocks again, and you see how they pretty much follow each other now. So we see we have voltage go in, and then we have a noticeable drop, and that drop matches across all those different battery blocks. That was under a hard acceleration. So we dropped a lot of voltage to hit that electric motor with that. So all 14 blocks should return a similar voltage under all conditions. They tested it under full electric mode, hard acceleration, and regenerative braking. So here's full electric, here's hard accel, here's a regen over here. There's another view here under regenerative braking. You can see how the voltage goes up. So that means it was charging and increasing the voltage in each block. So that is my voltage coming back. You can also use the driver information display for diagnostic purposes, or at least diagnostic aids. I don't know how, it's not a lot of diagnostic purpose, I guess, but a diagnostic aid. I can tell you what mode is this vehicle in. So in this case, the vehicle is off. In this case, it is the electric motor, the internal combustion engine only. So we can see how it runs the wheels, and then is running into the motor, which charges the battery. So that's charging. When it is all electric, we see the battery discharging, going through the electric motor and into the wheels. And then under regenerative braking, we can see the energy coming off the wheels into the motor and back into the battery. So there's our 4 different modes on it. So he took it on a road test, wanted to make sure all the battery packs were working properly, the battery blocks are working. So what they did was they took it on a road test and noted the values here. And then they put it in a spreadsheet, did a little bit of math. You want to see no greater than 0.3 volts between any of the battery blocks with this. So we see we're well under that. So that means the batteries are charging and discharging and recovering properly with that. And then here's just another example. This one's under EV mode. The one before that was under regenerative braking. So we can see the differences there. They're all fairly similar. They're all charging and discharging at a good rate, less than 0.3 volts. Here's another interesting thing that they captured, was that we see the battery voltage and the battery current are inverse of each other. So when the battery voltage goes down, the current is going up. When the current goes down, the voltage is going up. So they should act like this. We should have negative current when we have a positive voltage, and then a negative voltage when we have a positive current. So as we can see, this one's under EV mode, discharging, and this one's regenerative braking, charging. We see the voltage goes up, so the current flow goes in reverse. And then we see the current flow go up when the battery is discharging, because the current is flowing out of the battery into the motor. So as I said, a lot more scanner functions on this than we would have guided component test functions. So let's take a look at some of these different functions that we have available. So let's go into my vehicle history here. First thing I want to talk about, let's go in this 2012 Ford. And we're going to go into shop key first, because I want to look at the battery. If I recall, there's a TSB on this that I want to talk about. Okay, so on the Ford Escape hybrid, we'll call it an all-wheel drive. That's fine. There are TSBs on the battery, and should be. What's this one? So this is for outlines the process of requesting and utilizing a high voltage battery charger for recovering a discharge full hybrid electric vehicle high voltage battery. So as I said, the vehicle will not start with that. So when a full hybrid vehicle powertrain exhibits a no crank condition, it is important to identify if DTCs are preventing the engine from being cranked and if the high voltage battery must be charged. Discharged high voltage batteries are typically caused by repeated starting attempts or improper long-term vehicle storage. Base engine issues like fuel or ignition can cause crank no start concerns and ultimately a no crank condition. If the high voltage battery becomes sufficiently discharged, diagnostic trouble codes, these two right here, will set, resulting in a no crank condition. This bulletin, along with the published workshop manual, diagnostic procedures, will assist the service technician in understanding and resolving the problem. In order to recover a discharged high voltage battery, dealerships may request a rental charger, so that's really not of our concern. But a no start condition on hybrid electric vehicles is frequently mistaken for misdiagnosed as a start stall condition. A hybrid start stall crank no start video should be watched for commencing any repair actions on the vehicle. I think this actually works here. Let me see. So in our TSBs, we actually have media that plays too, which is kind of cool. I don't know if we'll be able to hear the audio.
Due to the unique design of Ford hybrid vehicles, there is one significant characteristic that has been found to mislead some technicians performing diagnostics to what appears to be a start-stall condition. The hybrid powertrain has system may rotate the engine for up to
uses planetary gears.
Will create a definite crank no start condition.
And they're going to make it so it doesn't start at all, and then you'll see what it sounds like.
This is how that same no start condition will look and sound from under the hood. The presence of
so it sounds like it starts and stalls, but it doesn't. So it'll attempt to start it a few times and runs it up to about 900 to 1200 RPM. We're not going to watch that whole video. You can watch it on your own if you want. But if I do that, it draws down the battery considerably. And then when it gets to a certain state of charge, won't be able to start at all. And you can't charge it with a normal charger at that point either. So you have to do some fancy work with a fancy charger in that case. I just figured I'd let you know on that because we kind of found that out from experience here in the diagnostic training department. So make sure if you do have a no start condition on a hybrid vehicle, not just that Ford, but that was a good example, that they don't always use a traditional starter. Actually, what I've found is that most of them don't use a traditional starter. So they use the high voltage battery. So just be aware when you have a no start like that. All right, let's go into this Pacifica. Let's go to the Prius first. Go to this Prius. Let's look at guided component tests. I think this is the one that has the test. So under some vehicles, when we have a hybrid vehicle, as long as we have information on it, we do have guided component testing on the hybrid electronics system. But like I said, there's not a lot of high voltage stuff for sure. But things like the cooling system pump, we can test it. There's a high voltage warning. There's a hybrid inspection mode that we can go into. Auxiliary battery, so that'd be the 12-volt battery. Safety gloves. Hybrid vehicle service plug. That's that service plug we need to disconnect in there right in front of the trunk area. We'll need to remove the rear deck to get to it. Additional information on that as well for safety down here. So that's in my hybrid vehicle section there. It also should be in the engine section as well. So if you don't see a hybrid section on a hybrid vehicle, look in engine as well. You may have a few things in there, but like I said, it's the high voltage, it's AC. It's not stuff we're really looking at normally with the scope. So I'm sure there's some stuff we could look at as long as we don't exceed the 400 volts DC on the machine there. So we're really focused on the scanner side. So to look at that, let's look in the Pacific. Actually, no, we can go back there. We'll look at that one first, then we'll go to the Pacific. All right, so this is a Prius V 2016, or Prius 5, I suppose. And for this, we'll want to go down to the hybrid vehicle category, and then we have the hybrid vehicle ECU. And then we'll see there's an inspection mode in there. There's some actuator tests. This is going to be things like inspection modes, battery cooling fan. Remember how we saw that cooling fan in there? Cranking requests on and off, electric water pump on and off, that sort of thing. And then we also have our data display. This is where we found those different battery blocks. So if I go into battery data, it's just going to be dummy data, of course, but you can get the gist of it. So there's our different battery blocks. Got the even numbers on one side and the odd numbers on the other side. So there's maximum, there's minimum, and then there's my different voltages there up to the 14 different blocks of 14.4. So we'll see that internally so we can read the battery, and that's where we'd be able to see that up and down weird stuff that Damien saw on that as well. So it also gives you internal resistance measurements on the battery. So a lot of data, worthwhile data in there. For it to exit here, if it will. There we go. Okay, insulation data, that sort of thing. So lots of different functions we can do with that. Let's go into the Pacifica one more, and we should be good to go. Got to get through my secure gateway. Okay. So once again, we have a hybrid vehicle section down here, and you can see there's a few more modules in here. So there's like a battery pack control module, hybrid control processor, which is this one. Let's see, miscellaneous functions. It's just ECU information. It's the other one that I was looking for. Let's see, this one. Okay, so there's some functional tests in there. Things like the chiller. Remember how he said there's the battery chiller, battery heater, high temperature shutoff valves, low temperature passive pumps, parking pall, fan duty cycles, coolant heaters. So there's a lot of functional tests that we can do. And like I said, a lot of data that we can read, miscellaneous functions that we can do, activate the pump and the low temperature coolant fill. As I said, there's a lot of times you have to bleed the pumps as well after a fill. So we have to do that. Resolver offset learn. So if I do electric motor work, clears the resolver offset for both motors, allowing the hybrid control processor to relearn the resolver offset on the next ignition cycle. I'm not going to do that. I think it gives me an error when I'm not connected, but we have all that in there as well. So it does some transmission functions too. So a lot of good information in there. Like I said, a lot of scan tool stuff you would need to do more over than the guided component test stuff. There are special hybrid voltmeters that you can use for that, capable up to like 1,000 volts. And as I said, any of our scopes are capable of 400 volts DC, not so much AC, but DC. So that's available for you as well. So with that, that's our little kind of intro to hybrid overview that we went through this week. So let's talk about next week. Next week, since this week is class number 5 of the year, and we do 5 classes in a row, then we repeat 5. We're going to go back to class number 1. So body electrical systems again next week. So if you missed it live, you got some questions you want to ask, certainly feel free to join us. Same time, same place, 6 and 9 Eastern. If you want to register to join on Zoom, go to snapon.com/OT to register there. Also, the early class, 6 Eastern, goes to YouTube on youtube.com/snapon-diagnostics. If you are watching on YouTube, please make sure you subscribe. It doesn't cost you a thing but a click. And then make sure you ring that bell so you get a notification anytime we go live or do any other sort of posts available. We are planning a lot more content this year, so it would be worth your while to subscribe and hit that bell so we can we'll be posting more than once a week sometimes. So definitely good to check that out. If you want to see any of our past classes, they're starting to build up here. I'm running out of space on the slide. Things like ADAS, data bus testing, component testing, we did that over the summer. HVAC, things like that. So all of that information is available once again, youtube.com/snapon-diagnostics. You can go check it out. There's a playlist for live training. Let's get to questions. Looks like we're a little light on Zoom, but we got a couple questions and comments on YouTube. I also want to make sure I mention my buddy Al. So Al does scanner training. We do training 4 nights a week here at Snap-on Diagnostics. Al does 3 of them, and then I do Tuesday. So Mondays, Al teaches Apollo. Wednesdays is Zeus, and Thursdays is Triton. So if you have one of these tools, you want to learn a little bit more about how it works, how to set it up, Al's your guy. So the first hour of all of these classes is going to be pretty much the same thing, just on a different tool. All right, Monday it'll be Apollo, Wednesday is Zeus, and Thursday is Triton. And it's going to be, let's set up your Wi-Fi. Let's set up your free Snap-on Cloud account so I can manage my secure vehicle gateway credentials, so I can manage sending customers my pre and post scans and screenshots and things. Let's get that set up. Then he walks through code to completion, real world case study on fast track intelligent diagnostics. And no matter what kind of technician, what level of technician you are, that will definitely help you speed up your diagnostic time, because it automates a lot of the things that we would normally do anyways, or if you're a little more advanced, some of the more advanced stuff, it actually automates as well. So definitely worth your time to check it out. That's the first hour. Then on Wednesday and Thursday, because the Zeus and Triton have the meter in there, he goes through guided component tests, scope, meter, bunch of different real world examples, different current ramp examples, things like that. It is really a robust class. It's about 2 hours on Wednesday and Thursday. It's a 5-minute break in the middle there. But Al's a wealth of information, 32 plus years with Snap-on. He actually came over before it was Snap-on Diagnostics. So he's been with us a very long time, definitely a deep well of knowledge. So make sure you check Al out as well. So let's take a look at questions. If you have any questions on Zoom, if you came in late, just find the Q&A button on the top or bottom of your screen. Click on that and we will get you you can type in your question and we'll get an answer. All right, let's see what we got on YouTube. Hello, Nick from the UK. Welcome. Always glad to see you. Hey, aficionado, welcome. Abel, hi. Good to see you. I remembered your first name this time. Let's see. Let's see. Best way to carry out a voltage drop on a hybrid system. I would say probably don't want to really mess around with the high voltage stuff. If you're going to do some sort of a voltage drop, maybe you would have to get into that battery thing, like the individual cells in there. I don't know if I'd really want to even mess with that myself. You might want to get in there and break that battery down. That's fine. But remember, the high voltage could be hundreds of volts, 200 volts there. So just be careful if you're doing it. It would be the same type of process you do on any other voltage drop, I'm sure. Jesse, welcome from Melbourne, Australia. Welcome. It's pretty early in the morning over there, but welcome. Able hybrid have a 5-volt reference. Yeah, so the gas engine, for all intents and purposes on most of the vehicles, it's just going to be a normal gas engine you'd run into anyways. So you're going to have 12-volt sensors and 5-volt reference sensors and things like that. So for the gasoline part, just think of it like a regular gasoline engine, because that's really what it is. It stops being a gasoline engine when we get to the transmission, pretty much is the way I like to separate it out. So it's gas on one side, electric vehicle on another side, and then we're mushed together at the bell housing, and that's where we get that hybrid vehicle. So yeah, it's the same type of 5-volt reference system on that side. Mike's Auto Diagnostics, no worries. You can be late. You can always watch the recording. You can always rewind this as well. So good to see you. Shifting gears. Hi from Utah. Welcome. And Soren, thanks for coming in from Birmingham, UK. Welcome. Another UK person coming in tonight as well. So thank you very much, everyone, for the questions and the comments. Always glad to see them. Always glad to have that conversation. Looks like we're good on Zoom. So thank you, everyone, for joining us on Zoom as well. And with that, I'd like to thank everybody. Thank you for taking a little bit of time out of your week to come spend with us. Hopefully we learned a little bit more about the basics of how hybrids work, and maybe a couple little diagnostic tips and tricks in there, and how we would use our scan tool and scan data to go through and check on the battery pack and so on and so forth. So with that, appreciate it. Enjoy the rest of your week. Enjoy your weekend. Hopefully we'll see you next week for Body Electrical Systems. With that, enjoy the rest of your day. Oops, I got a question. Oh, thank you, Draymond. Thank you. With that, thank you very much. Have a good